Hi guys, today we're looking at inheritance in ER modeling. Suppose we are asked to design a database for a bank company, and here's our initial design. On the left, we have checking account with attributes account ID, balance, and overdraft limit. And on the right, we have savings account with account ID, balance, the minimum balance, and interest rate. You can see that these two entity sets are quite similar. They got common attributes like balance and account ID, and also account ID is the key in both cases. It kind of tells you that there's some repetition or redundancy in our design, which is something you usually want to avoid. So let's see how inheritance can help us improve our design. The concept of inheritance in ER modeling actually comes from the object-oriented paradigm, which you are probably familiar with already. That's why although it might sound a bit weird, when we talk about inheritance in ER modeling, entity sets are also called classes. So what's inheritance? Inheritance involves a parent class and one or more subclasses, and the subclasses inherit from the parent all of its attributes and associations with relationship sets. In other words, for our banking account example, we need to define a parent class that will contain all the attributes that are common to both types of accounts. Account seems to be a great name for the parent entity set, so let's go with that. Next, we attach the common attributes, balance and account ID. Then we show inheritance using a notation that looks like this, which is slightly incorrect at the moment, so we'll come back to that later. Final step, since we've already defined these two attributes in the parent class, we can safely remove their duplicates from the subclasses. Now suppose we have another requirement that each account has to belong to a particular branch of the bank. That's something we already know how to do. It's a one-to-many relationship from branch to account. Every account needs to be held at a branch, meaning total participation, but a branch can have no accounts, so it's a partial on this side. Now compare that to this diagram which illustrates how our ERD would have looked like if we didn't make use of inheritance. Notice how it has two virtually identical relationship sets associated with branch, and this could have been much worse if we had a system that's more complex, say maybe with additional account types or other kinds of relationships involving accounts. So that just demonstrates why we use inheritance in ER modeling. It helps us to reduce redundancy in our design. Okay, let's go back to this incomplete notation we used for inheritance and find out the proper way to use it. And to do that, we first have to learn about the constraints. Just like with relationships, you can denote various kinds of constraints for inheritance. And to figure out which constraints apply to your inheritance, all you have to do is answer a couple of yes or no questions. In the context of our banking account example, the first question is, can you have an account that is neither checking or savings? And the second question is, can you have an account that is both checking and savings? Your answer to the first question will tell you whether your inheritance is partial or total. And the second one will help you decide whether it's overlapping or disjoint. Let's take a look at how to denote each of these constraints. If the bank doesn't provide any accounts that are neither checking or savings, then you're going for a total inheritance, which you can show by using a double line to join the superclass and the circle. Change it back into a single line and you get a partial inheritance. This means now you can also have an account that's neither of the two types, and in that case, the account would only have the attributes of the superclass, namely the account ID and balance. Next, we have overlapping versus disjoint. In the real world, you can't really have an account that's for both checking and savings. So if you want to enforce this ID, what you can do is place a D inside the circle, meaning disjoint inheritance. But if you replace that D out with an O, you get an overlapping inheritance, which allows for multi-typed accounts that belong to multiple subtypes. So here we have summarized all the different combinations of the constraints and the possible account types for each combination. Feel free to use this as a checkpoint and see if what you understood matches what's displayed here. But the better way to check your understanding is go through more examples, and that's exactly what we're going to do now. The first scenario involves people, where a given person may be a doctor and/or a patient, or maybe neither of the two types. You see that we have three entity types, person, doctor, and patient. And it's pretty clear that person is going to be our superclass and the other two will become the subclasses of person. A person could be both a doctor and a patient on the system, so that's got to be overlapping. And you could also have a person who's neither of the two subtypes, so it's a partial inheritance. Next up, we have employees who can be either permanent, casual, or contract. And you can further divide permanent employees into full-time and part-time. Since it's exactly one type of employment per employee, we make it disjoint. And since you can't have an employee that's none of these subtypes, we make it total. Likewise, every permanent employee has to be either full-time or part-time, so this part of the hierarchy has the same constraints. Lastly, we have a system consisting of employees and managers, where managers themselves are considered as employees. In cases like this where you have just a single subclass, there's really no point in defining any of the constraints. But I will leave you to think about that yourself, and I'm just going to show you the notation. All you need is a big triangle pointing towards the subclass and a pair of lines connecting it to the entity sets. And inside the triangle, you can write is a, which indicates that a manager is a type of an employee. So that's the gist of how you can apply inheritance in ER modeling. And that's it for today. I'll see you in the next video.